Okay, so with this SD-WAN solution and its component, we are available with various planes, orchestration plane, management plane, control plane, data plane. Orchestration plane is introduced with the device called vBond. So we introduce the first component or the primary component in the name of vBond. This vBond is going to validate, and this is going to authorize and authenticate and then authorize the other component to participate inside the fabric. vManage. So the vManage is the management plane device who is going to apply, who is going to push the configuration to vSmart, who is going to push the configuration towards to WAN edges. Now, this vManage is trusted into the fabric or not. This vManage is capable to push the configuration to other devices or not. This device is provisioned. So vManage is authenticated and then authorized by vManage. vSmart, we are going to have control plane like routing protocol decision with the help of vSmart. When vSmarts are introduced, like whether these boxes are authorized to communicate to form the control plane session or not. So vSmart associated authentication and then authorization to the fabric is determined by the vBond. Vanages, physical vanages, virtual vanages, cloud-based vanages, all vanages are authenticated and then authorized by vBond. So vBond is the orchestration layer device which is going to authenticate, authorize other components like vManage, vSmart, and vanages. If the device is not authorized by the vBond, and this is not going to be part of the fabric, and it's not going to be on the control plane or the data plane, or it's not at all like going to be part of the fabric and its related communications. So vBond sits at the orchestration plane and provides the centralized authentication. The typical authentication procedure followed here is digital certificate based. So we don't use pre-shared keys, or we don't use username and then password, or we don't use any token. We use only the digital certificate. Based on the device digital certificate, authentication and then authorization takes place inside the Cisco SD-WAN. As a mandatory component. Every component is introduced here. It is supposed to be with its unique device certificate. vManage should have its unique device certificate. vSmart to be with its unique device certificate. vanages to be with its unique device certificate. Similarly, vBond also to be with its unique device certificate. So vBond authenticates and then authorizes the components inside the SD-WAN fabric to perform the authentication. Digital certificate or certificate based infrastructure is followed. The second component is vManage. Basically, like vManage is the NMS management solution. So vManage is going to make SSH, and also this is going to make a net config session with other component. vManage via SSH or a net config, it can be able to push the configuration. So vManage can push configuration to vSmart. vManage can push configuration to vanages. Like device configuration and device management will be automated through vManage and its underlying protocol session. So vManage is basically for the device management, like to send the configuration or also to collect any statistical information, basic information into it. vManage is the centralized NMS in the SD-WAN fabric, and this vManage is a place where we can be able to see all the components together and fabric related configuration, fabric related management, and then troubleshooting. We're trying to perform it. vManage is open, or vManage is accessible through standard CLI, or we can be able to log in through standard GUI based on HTTP or HTTPS, or vManage is open with API. So programmability layer access, so that REST API calls or API calls can be placed in it. vManage sits in the management plane and establishes connection with other devices, and also collects the information and goes for the fabric management open with CLI, GUI, and REST API. Any questions in
Parthiban,
these
I
two?
have one
Yeah.
question. So
Sure.
this slide, are you going to cover all three component in this slide, or do you have plan to cover these component later also? Because I am asking this because I was not able to get all what you said. Maybe it's lacking some of the practical approach. I mean, the flow is missing here in this slide, so I'm not able to get what you are suggesting or saying.
Okay. Okay. So what I'm trying to do here is I'm trying to show like what devices are going to be available in the fabric. So I'm going to see a vBond and what is vBond, what is vManage, and what is vSmart, and then vManage. I'm going to create a first level of visibility towards to this, and then next slide we'll talk about vBond, what it does, and vManage, what it does, and then vSmart,
Okay,
what it
got
does,
it.
manages, and
Okay,
what
you
kind
have
of
more
data.
slides to cover. Yeah, thank you.
Yes, yes, I do have. Yeah. Right. So vBond is basically, as I told you, for the centralized authentication and authorization of the devices. vManage is basically for the device management. vSmart, vSmarts are going to be the control plane, like equivalent to BGP route reflectors. So WAN edges will have a routing adjacency with vSmart, where vSmart routing table updates will be synchronized or distributed to other devices. So instead of making vManage router to vManage router, point to point or direct adjacency and then direct routing protocol communications, we are introducing hub devices in the middle like the vSmart. So if data center vManage as a routing table update to be sent to campus, so data center devices will send them to vSmart, and vSmart will propagate them into campus routers and then branch routers and then any other routers connected in it. If a branch is having its unique routing table update, this routing table update will be sent to vSmart, and then vSmart will advertise to data center or campus or other vManages connected on the fabric. So instead of allowing routers to router direct routing protocol routing table update communications, so we introduce the vSmart. All vManages forms a routing protocol adjacency like OAMP routing protocol adjacency with this vSmart, via vSmart routes and then route information gets synchronized. That is control plane update. So apart from the routing protocol update or the control plane communication, vSmart will not do any functions in the SD-WAN. So apart from authentication, vBond does nothing. Apart from OMP routing protocol communication, vSmart they do nothing. And vManage is basically for the device management. Manages the customer edge devices, which going to send the routing table update and then routing table information with other devices, and also they are going to make the data plane communication. So the devices which will participate in both data plane and then control plane communication, the vManages. So now these four components we can see as a vBond for authentication, vManage for the management, vSmart for the control plane, and then vManages at the premises level. So four planes, and they are separated and then independent devices available for it. Any quick questions on this place? All right.
So, Parthiban, you said like we control, take care of routing exchange between the advantages, right?
Right.
So, what if we control devices down or not reachable for any advantage? How does branch to branch communication happens?
Okay. So we introduce vSmarts in a group. One vSmart, if you try to maintain, in case the vSmart goes down, router to router, the routing table adjacency and routing protocol adjacency becomes down. That means routing tables will be deleted from the local caches. So we don't want this situation. So we must make sure that okay, at least one vSmart is available, and this vSmart and associated OMP adjacency is retained for the advantages. So in a group, we are allowed to place three vSmarts and three OMP adjacencies or three control plane communications can be permitted from vManage to the vSmart. But at this moment, as a default behavior, two sessions will be established. vManage to vSmart 1, first OAMP adjacency, vManage to the second vSmart, second OAMP adjacency. So two OAMP neighborship or two OAMP adjacencies by default permitted from a vManage. In case one vSmart goes down, nothing, then second vSmart will provide the routing table update and routes will be synchronized, flow will be maintained. But if there is a situation both the vSmarts are down, then complete enterprise infrastructure is down because the routers are lost with the routing protocol. No learned routes into the routing table. Apart from local routing, nothing will be like permitted. But this situation is very much minimal because we have geographical separation of the vSmart, and also we have a various options like first group redundancy and then second group redundancy. By configuring different options for the redundancy, we can make sure that at least one vSmart is connected with this advantages.
So don't you think this is one of the drawback of this Viptela SD-WAN? Because if controller is lost, then the entire network is down, and that doesn't happen in ACI, for example, right?
No, ACI is a different solution altogether
Yeah,
because
I'm just giving one of the example. If we talk
Mhm,
about other vendors,
mhm,
let's take example of Silver Peak. There also we
mhm,
have got orchestrator. If we lose connection to the orchestrator, that does not impact the network.
mhm. Okay, in this case, what is a prerequisite is if Vanages loses connection with vManage, nothing will happen. If it loses the connection with vBond, even if the network is stable, nothing will happen. But if they lose the connectivity with vSmart, and obviously like the control plane informations will be flushed and network will go down. But it's a design.
So how much time it would wait, manage would wait before flushing out the control information?
Since OMP is a routing protocol, along with routing protocol, the timers could be there. For example, the timer for receiving the hello packet to retain the redundancy and also hold time. So 10 seconds is a default hold time. In this duration, the hello packet must be communicated between these WAN edges.
Mhm. So,
Particular.
so in this case, let's say I'm communicating through data center MPLS. I'm establishing cloud uh, V control. So in
Mm,
that case, for some reason, my data center internet link is down, but branches have internet link and branch to branch communication still can work. But because of the data center internet is down, my entire corporate network will be down because it does not have connectivity to vSmart, which is hosted on the cloud.
yes, so in this case, there are like options, increase the delay. The standard timers of the OMP can be modified. And also the
Mhm.
second option, instead of trusting on one vSmart, we can deploy various vSmart. For example, vSmart in the first cloud in one geographic location, vSmart 2 in a separate service provider in the separate geographical location. So when we are separating the vSmarts in different locations, we can make sure that redundancy and availability is available. But the basic design here, at least one vSmart should be reachable to the WAN edges so that through the vSmart routes are distributed.
Okay.
Hi, Parthiban, in my understanding, even if we lose the control plane connection with the vSmart, still there will be the data plane, right? Again, we can
Yeah,
extend the time and like that, but I mean the only impact will be that at that point of time, the new control plane information will not be populated into, I mean, populate into the data plane. I mean the VH device, right?
Yeah, this is what I
that's
also
right.
thought.
Yeah, this will happen, but the thing is the building the control plane and path selection inside the control plane, best path entries into the data plane. When the control plane goes down, vanages will wait for the control plane update. In case the control plane update is not received, then from the neighbor, whatever the routes are learned already, it should be withdrawn. So from the data plane. So the routers still follow the default behavior like IGPs or EGPs. So adjacency is built, learning the routing table update, put them into control plane, path selection, allow the best path into the routing table. In case the neighborship is down, wait for the timer. When the timer is elapsed, and withdraw all the routes from the data plane. The same situation will happen here with Cisco as well. In case OAMP is down, vSmart is down, and then OAMP session is down, we'll wait for the timer to expire. If this is elapsed, then whatever the routes received from the vSmart, which is down, and will be taken out from the routing table. In case only local data plane interfaces entry could be present, obviously like local routing could be supported to other branches or to the other data center, traffic won't be there. So we have to make sure that at least one vSmart is connected, and at least one vSmart and its associated control plane updates are received for this. We don't have any automation and we don't have catch in it. It may be an advantage or it may be a disadvantage, but this is the design.
So default timer, you said 10 seconds, is it?
Yes, the OMP timer. Yes.
I don't remember. I have read it somewhere that we can extend this. I mean, not sure about this OMP timer and all, but we can. I mean, we can do something so that we can extend this to 5 days or 7 days, most probably, with the same
No,
IPC key and all. Uh,
no,
I'm not sure about that, but
no. Keys are different. Keys are data plane encryption key. So that timer is something different because when we are establishing VPN tunnel between router to router, and inside that data are encrypted using the IPsec encryption key that will be valid for 8 hours, and that is valid for 16 hours, 24 hours. Even that timer also we can be able to modify that. But we are talking about the control plane. When router establishes OMP adjacency with the vSmart, if vSmart goes down, and the routes which is learned from the vSmart, which is centralized control plane, should be withdrawn from the data plane. I mean, from the control plane and then data plane. So how much time it should wait for it. So data plane is different, and different keys used for the encryption. And we don't maintain the same key. Even the keys are rotated on a regular interval. So key for encryption is different for the data plane, and the OMP control plane communication is something different. This is like equivalent to our IGPs and then EGP timer for the routing.
Do you have any other slides to cover the same discussion in future or?
Yes, yes, yes. I'm giving a visibility towards it, but initially I entertain a lot of questions to be addressed. That's what I'm doing. If you feel like I'm taking a lot of questions, then I will cut it.
Yeah, so maybe I think you may be having some of the topology diagram that includes more number of branches and then controller also, different kind of topology like fully mesh, hub and spoke, and then we can talk, I guess, let's see if we lose all the controller like
Yeah.
vSmart controller.
Yes, yes. At the time of control plane with vSmart OMP, we do have a detailed discussion on it. Since like the questions arrived, I need to address it, so I'm doing it.
one last interruption from my side. We are also going to cover this authentication part in details, right? Between these
Right,
controller components.
right, right. Yes.
Okay, that's
Yeah. Okay. Let's go in the flow. Okay. So we want the orchestrator. So primary authenticator for all SD-WAN component, facilitates discovery of the control elements by the edge routers. Discovery of the control elements in the sense like vManages are not provided with any information about vSmart where it's supposed to talk, and then vManage where it's supposed to be by the device administered. So vEdges are not going to be configured with any information about other controllers. vManages will talk with vBourne. When they are successfully authenticated, vBourne instructs the vManages to talk like what is a vSmart inside the fabric, and then what is a vManage inside the fabric. So fabric controller discovery and fabric informations about the controllers will be notified to vManages by the vBourne. Just to keep an information in mind, any devices, any vManages are deployed, any components to be deployed in the fabric, And to participate these devices into the fabric, they don't need any other devices and then associated information. We configure or we notify the vManages or the vSmart only about the IP address or fully qualified domain name of the vBond. I want to initialize a vManage, for example, Cisco CH. I'm finishing the interface IP, subnet mask, default gateway, DNS information, and I will be telling some basic thing. This is the vBond, and you talk to this vBond, and then once a vBond authenticates this particular vManage, vBond's responsibility to release like other vManage and then other vSmart controller informations. So notifies public VHs of their public IPs if behind NAT. So vBond collects the information about all components are with direct public IP addresses or they are behind the NAT. If they are behind the NAT, their public IP address and then private IP both will be collected. So vBond plays a key role in the orchestration layer. It authenticates, authorizes all the devices, and it provides the information about all the other controller to the vManages, and every device and its associated public IP information or private IP informations could be collected. vManage is a network management system, a single pane of glass for the entire SD-WAN fabric. vSmart controllers, the routing protocol boundary or vSmart the controller, distributes reachability and security information between routers. Reachability is basically the routing table update. Routing table or a control plane routing table informations are communicated between vManages via this vSmart security information. In case if we go with IPsec encryption, encryption keys also will be distributed by this vSmart. And then for the influencing of the fabric, data, and then app policies. So policies are created in the fabric, and for policies are distributed to other vSmart, other vManages via the vSmart. That means vSmart will distribute the policies. The way like route maps are created, route map influences the path of the control plane update as well as influences the data. Similar way, we do create the policy, and policies are enforced at vSmart, and then a vSmart will enforce it to the fabric side. So it has various responsibilities. VH routers sit at the perimeter of SD-WAN sites and provide connectivity across the fabric. VH routers handle the transmission of data, and VH routers are offered as the pre-integrated appliance in the hardware platform or software only virtual machine for ESXi, KVM, AWS, and Azure platform. So advantages are available in both physical and then virtual platform. So depends on our requirement, we can use it. So just a quick view. vBond for its unique role, vManage to its unique role, vSmart to its unique role, vManages to its unique role.